without further ado, we would now want to pass to the sort of the second part of today's workshop, which is looking at potential technology blocks on which work is ongoing, as we heard. And the first is RIS. And without further ado, I would want to pass the floor to Arman Shojaeifard, who in ETSI works on the RIS industry specification group. Arman, the floor is yours.
Yeah, thank you, Tony. I will go ahead and share my screen now. Is the screen visible?
Yes,
yeah, perfect. Okay, so good morning and good afternoon. My name is Arman Shojaeifard. I am with InterDigital Europe, where I serve as the chair of ETSI Industry Specification Group on Reconfigurable Intelligent Surfaces, ISG-RIS. It is a great pleasure to be here with you today to talk about RIS technology and the standardization activities we are doing on the topic at ETSI. RIS, which also goes under a number of other terms, such as intelligent reflecting surface, large intelligent surface, smart repeater, holographic MIMO, is essentially a new type of infrastructure node with reconfigurable radio surface technology, where the response of the surface can be dynamically tuned to the status of the propagation environment through control signaling. An illustrative depiction of RIS is shown on the slide here as a new system node with, for example, a planar structure of certain engineered materials, sitting in between access points and devices, where instructions to the RIS come from a system controller to the chip or microprocessor on the surface. And this is to then control how the signals impinging on the surface are impacted in the electromagnetic domain, so what we call layer 0. And a main use case that has been talked about a lot is to use this RIS component in the form of an intelligent mirror to achieve tunable reflections, and this can be to improve coverage enhancement, which is a key challenge in 5G deployments today. So going a little bit deeper into what set RIS apart from other wireless technologies, so we can look at the individual terms in the name. So reconfigurable means the response of the surface can be modified. This can be reflection, refraction, absorption, focusing, modulation, or any combination of these. Intelligent means that the tuning of the surface is handled dynamically and potentially in real time. And we already talked about the role of a controller there. Surface means that the composition is done in a certain way to allow certain electromagnetic characteristics. And this is using mostly passive components. For example, integrating switches and phase manipulating units, so pin diodes, varactor diodes, liquid crystals, essentially to control phase and impedance patterns on the surface. And this in turn results in RIS being potentially more favorable in terms of weight, power consumption, and ease of deployment. And these characteristics really set RIS apart from your conventional deployment solutions, including repeaters, relays, and fully stacked cells. And the associated characteristics has resulted in RIS be fast emerging as a key technology block for future wireless systems, including 6G. Of course, we are likely to see RIS in some shape and form in 5G Advanced as well, and we already see it in the current release 18. And there are a host of potential use cases that target at utilizing these characteristics of RIS. And these include aiming to enhance existing key system performance indicators, for example, coverage and capacity, but also importantly to enable new types of wireless applications. So these include aspects, for example, such as further localization and positioning, wireless power transfer, ambient backscattering, and so on. RIS can be potentially deployed both indoor, outdoor, in offices, airport, shopping malls, lampposts, and it can potentially take any shape and be integrated onto objects. And this would also mean that the RIS could be very important as far as sustainability requirements are concerned going forward. And RIS also has important synergies with other technology areas. For example, as was discussed in the previous session, RIS can be made to operate in frequency bands from sub 6 gigahertz all the way to sub terahertz and then terahertz, but also very important that other elements such as applications of AI ML are likely to be used to enable RIS operation and optimization and really get to the end goal of the technology, which is to enable smart propagation environments by converting a channel, which has always been a passive actor in the previous generations, into a service. RIS has attracted a lot of interest, and there are already a number of EU collaborative projects working on RIS-related technologies and the realization and evolution. This is not a comprehensive list on this slide, but importantly, you can see the likes of HexaX and RISE 6G and Ariadne, to name a few. In addition, there has been activities in IEEE, including various initiatives, such as special interest groups, also best readings on RIS technology. We also observe a number of early RIS prototypes being reported in the literature, including demonstrations by entity Docomo utilizing RIS for aiding millimeter wave communications. There has also been attempts to bring RIS onto standards as early as release 18 in 3GPP. So following the RAN plenary in December, RIS was considered premature to be included in the work program, but we already see some elements of it in release 18, and this is likely to be brought up in release 19. RIS has a very rich roadmap, and we see a strong support for RIS as a key technology block for future 6G, and an example of this is the various contributions made to the IMT 2030 Future Technology Trends report on the technology. Recently, ETSI has launched a industry specification group on RIS technology. So a first ISG that is looking at the beyond 5G, 6G topic. And the mission of the ISG RIS is to review and establish global standardization for RIS technology. And this importantly includes in the first phase, exploring and studying RIS across a wide range of use cases and deployment scenarios, and identifying any specification requirements that must be met. The ISG RIS has very strong ties with multiple EU research projects, and we have key stakeholders there. And the vision of the ISG RIS is really to make this important link between research to pre-standards, to standards, and eventually market. Activities of ISG-RIS will importantly be complementary to the work that is happening within both ETSI and outside ETSI, and synergies with the wider groups is absolutely critical to ensure interoperability and ensure broader industry adoption. In terms of the progress of the ISG-RIS, so in early June of 2021, the group was approved by ETSI Director General following consultation with ETSI Board. And we officially launched the group as of end of September of last year with a kickoff meeting. We have continued to attract new members and participants to the group, and we are currently more than 30 members in the group. Importantly, a number of key operators, vendors, and manufacturers, but also very importantly, universities and research institutes that are part of the work of ISG-RIS. The first quarter of the group saw the establishment of the work program, and that is divided into three work items. So one is on use cases and deployment scenarios to understand what are use cases where RIS is an attractive deployment solution. A work item 2 on technological challenges, for example, in the microelectronics domain, but also importantly, the potential impact on architecture and requirements as far as specifications are concerned. A third work item that looks at the communication models and channel models and evaluation methodology, focusing on the characteristics of RIS. We have done a number of outreach activities, including liaisons sent out to various groups, including 3GPP. Looking at the longer term roadmap of ISG-RIS, so we will continue the activities in the first phase for 2 years, and this is the exploration and gap analysis phase, and the deliverables of the group will be mostly group reports, white papers, proof of concepts. We will establish relationships with other groups, and this initial release will be followed with an initial specification release, where we intend to introduce certain specifications through production of group specifications and a closer collaboration with other groups. And this phase will be then followed with a final specification phase to ensure that the results and findings of the group are streamlined into main SDOs, notably 3GPP. So in terms of key takeaways, RIS is strongly considered a key technology block for future wireless systems. ISG-RIS was formed to streamline European, but also importantly coupled with global initiatives, research activities on RIS, such that the technology would be going into future standards by having research and research partners as part of that journey. And the group is currently working on pre-standards work, including the identification of use cases and covering on the identified scenarios and clearly documenting the relevant requirements. Very importantly, ETSI and non-ETSI members are welcome to ETSI ISG-RIS. This is a unique opportunity to be at the forefront of the evolution of 5G-Advanced and future 6G. And here I would very much like to emphasize that we would greatly welcome participation from players from South Korea, importantly operators in the work of the ISG-RIS. The previous session saw, I think, a consensus on the importance of vision and the right use cases. So we would very much welcome working and participation from colleagues from South Korea. So with that, I'll hand over to you, Tony. Thank you very much.
Thank you, Arman. And immediately I pass the floor to our Korean friends. Dr. Lee, the floor is yours.
Hello, this is Nikon.
Yes, we can hear you.
Hello? Okay, thank you. Sorry. I will share my screen. Okay, yeah, thank you for having a chance to present our view for 5G Advanced. This is only from ETRI. Yeah, regarding RIS, I don't have much information on that, but one of our research group will start the research on RIS. So if they have some concrete research, yeah, we can discuss together later. So this time I will present our key technologies on 5G Advanced. As you know, in the last 3TV plenary meeting, the work package for release 18 was approved. With the release 18, 5G Advanced to start the second phase of 5G, and it will bring a new wave of wireless technology innovation. ETRI also would like to join this new technology trend. So in this talk, I present ETRI's view on 5G Advanced on key technologies we think. Okay, this is the contents. Firstly, I introduced the tentative roadmap, including general consideration on 5G Advanced. And then I will introduce our selected items and also provide some more details on motivation and the expected work scope on each item. And last one is a brief summary on this talk. Okay, this is our expected timeline for next generation. Since the release 18 is the first release on 5G Advanced, so it can be served as the bridge between now and the new next generation. And 5G Advanced items should be also balanced between enhancement of existing features and introduction of new features, and also balanced over short-term market needs and long-term potential demand. In this presentation, I will introduce selected key items for 5G Advanced we think. This is the list of the selected items. The Inest multi-therapy transmission and extension up to 140 gigahertz, and enhancement of position, evolution of duplex operation, and AIMS study. In the following slide, I provide more details on each item. Okay, the first one is the enhanced multi-therapy transmission. As you know, the demands for user-centric communication service are increasing. For example, XR service is one of the most important application, and it requires high data rate anywhere. However, NI systems still suffer from poor cell edge performance due to the limitation of existing MIMO and comp technologies. So, user-centric connectivity networks are necessary for this. Current multi-therapy transmission scheme should be enhanced. For enhancement multi-therapy transmission, we think the following works will be necessary. Firstly, it needs to identify the operating scenarios. We can consider both FR1 and FR2 operation. Regarding duplex mode, it is better to focus TDD first to minimize the CSI feedback overhead. And it also needs to study network coordination scheme for supporting coherent joint transmission. In order to support coherent data reception from multi-therapies, the related measurement and reporting should be enhanced. In release 18, supporting coherent joint transmission will be studied, but it is limited to FR1. But we think coherent joint transmission should be also supported in FR2. And we also think the current number of therapies for multi-therapy transmission is not enough. Even though up to 4 therapies will be supported in release 18, we think more than 4 therapies should be supported. The related beam management for simultaneous reception from multi-therapies should be also enhanced. Finally, evaluation of performance and implementation complexity will be necessary. Okay, next one is the supporting frequency range up to 114 gigahertz. Unfortunately, this item was not selected for release 18. Extension up to 71 gigahertz was completed in release 17. It is generally targeting for EMBB enhancement and focusing on the basic features. So we think the further optimization for particulars will be needed, and extension of the spectrum further is promising to provide ultra-wide bandwidth. And also, we think it is the right direction for the future. The ultra-wide bandwidth can be used for enabling various use cases, such as extremely high data rate service and extremely high accurate precision service, and others. For this, evaluation methodology, including channel model and icon model, should be studied, and the scale of new waveform should be also investigated for supporting low PAPR transmission. Of course, the existing waveform will be a baseline. Enhanced beam management, considering larger number of narrow beams, should be also studied. Due to extremely narrow beams in high frequency region, it might be difficult to maintain TXRX beam alignment. So transmission using multiple beams within a slot can be considered for beam diversity. And based on location, different beams can be used. For example, wide narrow beams can be used for set HUE, and relatively wide beam can be used for center UE. Yeah, the next item is non-terrestrial networks. Even though this item is included in release 18, the work scope is a bit different from our expectation. Anyhow, release 17 is the first release for NR-N10 system with essential functionalities. However, it is heavily relying on GNSS and focusing on transparent payload, and only support direct connection between each satellite and G-Node V. We think NTN technology can extend coverage and availability of mobile service into the 3D vertical domain. So further optimization and enhancement should be continued in the following releases. For NTN enhancement, we think enabling operation with reduced or without GNSS should be studied in order to increase availability of NTN service. Operation in limited GNSS coverage should be supported. However, in release 18, it is assumed UE with GNSS capability only. So we think further enhancement on this aspect should be followed during the following releases of 5G Advanced. In the next, it needs to study enhancement of mobility and interworking between terrestrial networks and non-terrestrial network and non-terrestrial networks. More specifically, the following items: regenerative payload interference between satellite, vertical connectivity, and others need to be studied. The mobility aspect is included as one of the release 18 objectives, but the details on this item will be updated later. So we will keep pursuing to reflect our proposal on this aspect. We also need to study additional enhancement for coverage and power saving, for example, simplified protocol and minimized SIB reception, and the study of a new waveform. Regarding this aspect, some part of proposals will be studied in release 18 and others do not. So it should be studied further in the following releases. Okay, next one is the further enhancement of the positioning. In release 16, basic NR positioning was supported, and positioning enhancement were completed in release 17. However, it is only available in the limited scenario. And commercial interest in high frequency, higher positioning accuracy is still increasing. At the same time, wideband such as beyond the 52.6 gigahertz is also available. And as the operating frequency range becomes higher, narrow beams and ultra-dense network will be also deployed. In addition, the demands for high accuracy positioning are also growing from vertical domains, such as side ring, webcam, public safety, and so on. Positioning enhancement are also included in release 18, and in this case, most objectives are quite aligned with our proposal. For further enhancement of positioning, we think firstly increased bandwidth should be considered for improving positioning accuracy. Aggregation of DL positioning RS and UL positioning SRS bandwidth was discussed in release 17, but not adopted at the time. This aspect will be discussed again in release 18. And while the bandwidth in loop frequency range will be beneficial for improving positioning accuracy, however, this part is not included in release 18. Study of enhancement of power consumption and latency reduction is also necessary, such as positioning support in RSI'd state and a periodic semi-percent transmission and reception of the PRS. We also think it is necessary to study advanced technologies for enhancing positioning accuracy, such as carrier phase-based positioning and AI/ML-based positioning schemes. And both schemes are included in release 18 and will be studied. And then many other vertical use cases, such as side ring positioning, vertical positioning, will be studied in release 18 locus call. Okay, next one is the evolution of duplex operation. The necessity of more dynamic and flexible downlink and uplink resource adaptation is increasing to support emerging new type of service, which have dynamic downlink and uplink traffic variation. And it is also quite different from conventional one. Efficient resource utilization using existing TDD configuration is limited. And it is also necessary to further enhance latency reduction for emerging service due to limit of uplink resource in legacy TDD configuration, traffic and feedback latency are limited. The advanced duplex mode can be also used for coverage enhancement. Generally, uplink is the bottleneck for coverage due to the UV power limitation. Extension of uplink transmission time by the advanced duplex mode can be used for increasing transmission power. For the evolution of duplex, there are two main operations. One is the sub-band full duplex, and the other is the full duplex operation. However, full duplex operation was excluded in the 18th work scope. Except for that, most part of objectives are also aligned with our expectation. We thought firstly, feasibility of duplex operation should be carefully investigated. For this, deployment scenario need to be identified. It is also need to study interference scenarios. Based on that, evaluation of system performance and the investigation of the specification impact should be followed. Even though full duplex operation is out of scope at this moment, we think a full duplex operation without any constraint should be supported finally. So we will continuously try to support full duplex operation in such TTA area. Okay, last item is AI/ML. AI/ML is very well known that it is very effective and powerful tool to solve intractable problem in many technical areas. And AI/ML can be applied to many difficult and unsolved wireless communication problems. And in some areas, we show the better performance comparing to conventional techniques. So we thought the study on potential application for AI/ML needs to be started in 5G Advanced. AI/ML study is also included in release 18, and work scope also quite aligned with our thinking. Since AI/ML is a bit fresher than other technologies, we thought it needs to start with the study on use cases of deployment scenarios. For use cases, there are many candidates. CSI measurement and channel estimation, ISO word positioning, beam management, and so on. Most of the candidates, we think, are included in the initial set of use cases for release 18 study. Based on the initial set of use cases, evaluation methodology for AI/ML should be studied. And then, if needed, investigation on standardization impact for AI/ML can be followed. We will try to ensure that related work items for standardization can be continued in the following releases. Okay, here is the summary of today's presentation. For 5G Advanced, we propose to study the several key technologies. In order for 5G Advanced to play role of stepping stone to the next generation, we think these items will be key technologies. Of course, other items are also very important, including contiguous enhancement of the existing feature. As I mentioned before, some of items will be treated in range 18. However, many of them still remain and should be covered in the following releases of 5G Advanced. In order to do so, we will try to pursue standardization of the remaining parts. Okay. Thank you for listening to my presentation. Yeah, that's all.
Thank you, Dr. Lee. And this concludes the part about a potential technology block RIS.